Okay, so we're continuing the story. When I was looking at the what you need to know list, I noticed that I skipped over the terms precision and accuracy. And these are two important terms, so I put them up here on the board so that you could put them in your notes. When you're measuring things in the lab, there are two words that we use quite often. Are the measurements precise? What is precision? Precision refers to the closeness of the set of values obtained from identical measurements of a quantity. So let's say I gave you a sample and I told you it's 125 grams, okay? And then you went and you weighed it and you got 119.5 grams the first time. And then you weighed it again and it was 119.4. And then you weighed it again and it was 119.5. So these three numbers are not accurate because the actual value is 125. However, the three numbers are precise. Like you tried it 3 times and all 3 times you got the same value or very close. So they're very close. These three numbers are precise. If you got, for example, something like this, you got 126.0 grams, and then you got 125.0 grams, and let's say you got 124.0 grams. These are your three different times when you did it. If you take the average is 125. So these three values are, when you take the average, it's accurate, but they're not precise. They're not exactly the same. So they're not close. And that's the main difference between precision and accuracy. Precision is all about reproducibility, doing something more than once, and getting the same value each time. Accuracy is the closeness of a single measurement to its true value. So what I did here was I showed you an average, but let's say you just did it once and you got 125 grams. It's accurate, you're done. Okay? So that's the key thing that I wanted you to know about that. All right, so I'm gonna put some numbers on the board here just to cement the information that we covered before. And we'll get into calculations with measured numbers. So let's say I have this number here, 2.083, let's say liters. And this number here, 0.0020 grams. And then I have this number here, 8,020 milliliters. Okay, so 2 volumes and 1 mass. And I ask you, how many sig figs are there? Well, you see here that this 0, remember how we said it's a confined 0? So because it's a confined 0, it's between 2 significant digits. This is significant, so this one has 4 sig figs. Over here, remember how we talked about leading zeros? Leading zeros are not significant. So none of these 3 guys are not significant. This one here is a trailing 0 at the end of a number, but it's to the right of the decimal. So this is significant. And so this is just 2 sig figs over here. And for this one over here, there are 2 types of zeros. This is confined and this is trailing. The confined is significant. The trailing, because it's to the left of the decimal, it is not significant. So this one has 3 sig figs. What if I wanted this 0 to be significant? Remember how in the last video I used the word ambiguous and then switched it over with unambiguous? Okay, what if I want this 0 to be unambiguous? I want to make sure that everybody knows that it is significant. Because the way I've written it here, it's not significant. How do I force it to be significant? You turn it into scientific notation. So what are the rules for turning something into scientific notation? You take the decimal, which is right here, and you move it 1, 2, 3. so that you have only one digit to the left of the decimal. So, and then you keep all of the digits that you want to be significant, you keep them in that number. So it would be 8.020. But because we moved the decimal 3 places, we need times 10. And the exponent we use is how many places you move that decimal. So you moved it 1, 2, 3, so it's times 10 to the third milliliters. Now, how many sig figs do we have in this number? 1, 2, 3, 4. You got the 4 sig figs that you wanted. Now, this is unambiguous. It is not ambiguous at all. We know for sure that it is a trailing 0 to the right of the decimal. It's definitely significant, okay? So you're going to be turning things into scientific notation to force those weird zeros that are trailing, to force them to become significant if you need to for a final answer. Okay? All right, so what are some rules for calculations? Well, when you're doing a multiplication or a division, the final answer has to have the same number of sig figs as the least number of sig figs in one of the measured quantities. So let's say you had 12.35 centimeters and you want to multiply it by 8.9 centimeters and you want to multiply it by, let's say, 10.1 centimeters. So this is length, this is length, this is length. If you're multiplying length times length times length, you're getting volume. So centimeters cubed is volume. I don't know if you know this, but you should know this. 1 centimeter cubed is equal to 1 milliliter. All right. So how many sig figs do we have here? We have 4 sig figs here. How many sig figs here? 2. And for this one here, we have 3 sig figs. So you need to get your calculator. Make sure you guys invest into a scientific calculator. Doesn't have to be pink. But I have this handy dandy TI-30. I mean, you can obviously use your graphing calculators, but you're not going to be able to use them for exams. So make sure you have your own simple scientific calculator. Like I said, this is a TI-30X. Here's this. All right, works well. All right, so I'm going to put these numbers in. 12.35 times 8.9 times 10.1. Okay, so I put all these numbers in, and what do I get? I get 1110.1415 centimeters cubed. Always put your units there. You're not allowed to leave that number that way. In a chemistry class, you have to pay attention to sig figs, okay? Why do we have to pay attention to sig figs? Because we used a tool, a ruler, to measure this. And we are limited by the limits of that ruler. And the least number of sig figs it gave us was that 8.9, that 2 sig figs. So our final answer, according to the rules of multiplication and division, has to be 2 sig figs. Okay, well, obviously this is 1, 2, 3, 4, 5, 6, 7, 8 sig figs. The easiest way to do this is to quickly switch this number to scientific notation, and that way you could just drop all the extra digits. All right, so I'm going to go ahead and do that. I'm going to move the decimal 1, 2, 3 spots. Okay, so now I've got 1.11011415, and I moved it 3 spots, so it's times 10 to the third. If the original number is bigger than 1, it's going to be a positive exponent. If the original number is less than 1, means you're moving the decimal in the other direction, it's going to be a negative exponent. So this original number was bigger than 1, positive exponent. Okay, now we can drop all the digits that we don't want. How many digits do we want? We only want 2 digits. So we get to drop all of these. If this digit here was a 5 or higher, we would round up. So if this was like a 6 or a 5, it would be 1.2. But since it's below a 5, we leave it. So our final answer is 1.1 times 10 to the third centimeters cubed. Okay, so that's the rule for multiplication and division. Plenty of practice in your first math lab. Plenty of practice in the homework too. The other rule for sig figs, calculations with sig figs, are addition and subtraction. So with addition and subtraction, you don't round to the least number of sig figs. What you do is you round to the least number of decimal places. What do I mean by that? So let's say I've got this number here. So 125.6, and then this is 1.75, and this is 28.327. So I want to add all these numbers. Okay? So you go ahead and add them. 7, 7, 16, 15. Hopefully I'm doing the math right. So 155.6. Let's pretend centimeters. Let's pretend this is centimeters. Okay? You're doing a perimeter of something, whatever. All right. So rule is least number of decimal places. So this is 1 decimal place. This is 2 decimal places. This is 3 decimal places. What do we round to? 1 decimal place. So cut this off right here. So it's going to be 155 point. Notice how this is a 7, so it's a 5 or higher. So you round up. So your final answer is going to be 155.7 centimeters. That's the rule for addition and subtraction. All right, so I gave you guys the rules for calculating with paying attention to sig figs. One thing that is really important is that when you're multiplying numbers and you're multiplying an exact number with a measured number, the exact number, remember, has an unlimited number of sig figs. It's infinite. So we don't focus on the sig figs of the exact number because that's infinite. You focus on the sig figs of the measured quantity, and you'll see that when I give you guys a couple of examples when we do dimensional analysis and conversions and things like that. Okay, so we will continue on this lovely story in the next video.